Example 5. Solve the equation log of 4x squared to base 25 equals to log of 3 minus x squared to base 5. Given log of 4x squared to base 25 equals to log of 3 minus x squared to base 5, and we are required to find the value of x. Since all bases share a common factor of 5, using the change of base formula rule, let's introduce a new base of 5 in this logarithm. This implies that we have log of 4x squared base 5 divided by log of 25 base 5 equals to log of 3 minus x squared base 5. So we will have log of 4x squared base 5 divided by 25 is the same as 5 squared. So this becomes log of 5 squared base 5 equals to log of 3 minus x squared base 5. And this will become log of 4x squared base 5 divided by, from power rule, 2 will become a coefficient of this logarithm. And this will become 2 log of 5 base 5 equals to log of 3 minus x squared base 5. This is the same as log of 4x squared base 5 divided by, from ident rule, log of 5 base 5 is the same as 1. So we have 2 times 1, which is still 2, equals to log of 3 minus x squared base 5. On cross multiplication, you have log of 4x squared base 5 equals to 2 log of 3 minus x squared base 5. This is the same as log of 4x squared base 5 equals to, on reversing the power rule, this will become log of 3 minus x squared base 5. Since the logarithms on either sides are to base 5, based on equality mathematical property, let's equate the arguments. This implies that 4x squared equals to, open bracket, 3 minus x squared plus c squared. On obtaining a square root on either sides, we have root of 4x squared equals to root of 3 minus x squared plus c squared. We have, this will become 2x equals to 3 minus x squared, and this is the same as x squared plus 2x minus 3 equals to 0, of the form ax squared plus bx plus c equals to 0. This is a quadratic equation. So let's use a calculator to obtain the possible values of x. Go to mod equation, that's 5 degree 2 quadratic equation. Our value of a, the coefficient of x squared, that's a 1, and the coefficient of x, that's 2. The coefficient of x to power 0, that's negative 3. x1 equals to 1. So either x1 equals to 1 or x2 equals to negative 3. But before we conclude, let's first test for whether the obtained values of x satisfy the equation from the problem. When x equals to 1, remember we have x equals to 1 or x equals to negative 3. So let's substitute for x equals to 1 in this equation. We'll have log of 4 into 1 squared base 25 should be equal to log of 3 minus 1 squared base 5. And 1 squared is the same as 1. So this is the same as log of 4 base 25, and it should be equal to log of 3 minus 1, same as 2 base 5. Using the change of base formula rule, let's introduce a base of 5 in this logarithm. So we will have log of 4 base 5 divided by log of 25 base 5, and this should be equal to log of 2 base 5. But 4 is the same as 2 squared, so we have log of 2 squared base 5 divided by 25 is the same as 5 squared. So we have log of 5 squared base 5, and this should be equal to log of 2 base 5. And from power rule 2 will become a coefficient of this logarithm. We have 2 log of 2 base 5 divided by, the same applies to this, 2 will become a coefficient of this denominator, 2 log of 5 base 5, and this should be equal to log of 2 base 5. The 2 will cancel with the 2, and we will remain with log of 2 base 5 divided by, from ident rule, log of 5 base 5 equals to 1, and this should equal to log of 2 base 5. So we have log of 2 base 5 equals to log of 2 base 5. And since the logarithm on either sides are 2 base 5, let's equate the arguments. So we have 2 equals to a 2. And since the left hand side equals to the right hand side, therefore our value of x indeed equals to a 1. Let's test for when x equals to -3. From the problem, we have log of 4x squared base 25 equals to log of 3 minus x squared to base 5. Let's substitute for our x equals to -3. This will become log of 4 into -3 squared to base 25, and this should equal to log of 3 minus -3 squared base 5. -3 squared is the same as 9, and 9 times 4, that's 36. So we have log of 36 to base 25, and this should be equal to log of -3 squared is the same as 9, 3 minus 9, that's -6 to base 5. Using change of base formula rule, let's introduce a new base of 5 in this logarithm. So we have log of 36 base 5 divided by log of 25 to base 5 equals to log of -6 base 5. And we have log of 36 base 5 divided by 25 is the same as 5 squared. This is log of 5 squared to base 5 equals to log of -6 base 5. This becomes log of 36 to base 5 divided by, on applying power rule and ident rule on this will become a 2 equals to log of -6 base 5. On cross multiplication, we have log of 36 base 5 equals to 2 log of -6 base 5. And this will become log of 36 base 5 equals to, on reversing the power rule, this will become log of -6 squared base 5. So we will have log of 36 base 5 equals to log of -6 squared is the same as 36 base 5. And since on either sides we have log to base 5, we should equate the arguments. So we have 36 equals to 36. And since the left hand side equals to the right hand side, therefore also the value of x equals to -3. Let's conclude. Therefore, x equals to 1 and x equals to -3. X equals to both 1 and -3. To best understand the basics, rules, and special cases in logarithm, check out this video. The full link is in the description. To support us, don't forget to subscribe to Outek Math, and for more examples, check out the links in the description. Otherwise, see you in the next.